Okay. Looks pretty clear.
It does, doesn't it?
Yeah, yeah.
So I can't actually bond to this part because it's for application development work.
Uh-huh.
And I don't have the specific wire size in for this application. Also, it's difficult. So I'm not going to demo a difficult real live application. If I had the dummy sample that I had doesn't have any more space on it and it looks really messy. So
Okay.
this is
Yeah, that's fine.
clean sample. At least they get an idea of, a silicon component and where the pads are and the trace pads and
Yes,
there's
that
so
looks good.
but maybe if they haven't seen anything like that, then just looking at the aluminum plate is kind of boring. Although I do make funny shapes, so yeah, I think that will give everyone a range, knowing the capabilities of the system, what kind of applications you'd use it for. So we just for my background on wire bonding, we also do like training classes. And the training classes basically it's a 2-day class, and the first day is wire bonding basics and parameter adjustments and basic bonding techniques. And then we have to spend an entire second day on bondability, failure analysis, pull test, and inspection, and getting everyone the idea of knowing what a good bond looks like. So we always say that half of wire bonding is inspection, knowing, visually seeing a good bond and knowing whether or not you need to do a pull test or something to qualify. It is definitely half the battle and gets you closer to finding what good ranges are. So I don't expect everyone to be an expert in inspection, after wire bonding a few times. And so with universities, we don't leave you hanging. So over time, as new applications and different departments create different things, and there's different applications that come to the system, at any time you can always contact me, email me, call me, and you can tell me what your wire size is, what are you bonding to, what are your issues, is it sticking, is it non-sticking, and so then we can start going in through their application specific. So
that sounds great. Yeah, and also for your information, most of the students in this class probably in the past did not use wire bond before. Therefore, I think this session, if you can tell us some basic about this wire bonder and also how to operate this wire bonder, that will be sufficient. Yeah, okay. Yeah. And definitely, if in the future we decided to do a lot of bonding and encounter some questions about the further analysis, I hope you won't mind to give us some more tutorials. But yeah.
And then as well, we always offer free evaluations. So a lot of times universities are very frustrated with trying to bond to a sample. And I say, let me worry about the frustration. I've had more years of experience. Pack up a sample and send it to me. As long as it's a little bit more trickier with heavier wire, just because I find every application is using a different size wire.
Yes.
Fine wire, 25 microns is extremely common. So a lot of the fine wire applications, we're always dealing with the same wire size. So I usually always have stock of that. If it's heavy, then I just need to make sure that I have the same wire and tools in, and then I can give your evaluation a better development.
And I noticed that we already started the class. Hello, everybody. For today, as I said, we are going to have a tutorial about the wire bonder provided by Jonathan. Maybe Jonathan, if you can briefly, excuse me, briefly introduce yourself a bit, and then you can go ahead to do whatever demo you want.
Okay. All right, well, hi everyone. And we're gonna start today. This is the HB30, the heavy wire semi-automatic system. Our plan today is we're gonna run through the operation of the system. We're gonna go through some bonding, and then we're gonna go through the control screen, and then we'll start backing up on how do I install the wire, how do I install tools, and then how do I adjust parameters, and then we can go into more questions and answers about application or anything about the system or the controls. So with the system, we have here the main power for the system. So there's an on and off switch right here. All right, and this will flip the system on and off. Once the system is on, the lights will automatically come on. So you have fiber optic cable lighting here. You can present them closer to your sample. It will give you better lighting. You have your microscope. You may or may not have the Trinoc microscope. So mine has the photo tube with the video camera, and then I have it plugged into a separate monitor. Let me just pin this video. All right, so let's just once the system is turned on, it will show you to the control screen of the last program that was running on the system. And then we have your work holder here. So the work holder has a locking screw here. So you'll loosen this screw and then you'll be able to spin the base, and this will change your height. The top plate of the work holder is mechanically clamped with a pinch. So if we pinch these pieces together, then we can slide out and add more components. If the component is bigger than the clamp spacing, then you can adjust the back brackets and loosen these two screws and slide the bracket into another position. All right, once our device is put on our work holder, we can then move it over to our stage. Typically, when we start with our first program, even if we were running successfully yesterday and I'm coming in today, I'm just picking right up where I left off, I still recommend running a height setup. And that's probably the first thing you'll do with any program. So when we want to run a height setup, you can, let me just get this down a little bit more. All right, so the height setup button is in this corner. It says height setup. We call this our main bond screen. In the bottom right-hand corner is the advanced settings button. This will take you to our setup screen. And the setup screen also has access to the height setup button here in the corner. So we can run the height setup in this screen or your main bond screen. I like to kind of run it in the setup screen because these three heights are the heights that get calculated with our height setup. So when we run a height setup, the tool needs to know where the height of our first bond location is, the height of our second bond location, and then what it does is it automatically factors in a safe travel work height, which is automatically 2,000 microns or 2 millimeters above whichever height is taller. So if we do a height setup and the first height is lower than the second one, then I'll use the second one and then add 2 millimeters, and then that will be our safe travel. If I don't think 2 millimeters is enough, or I have other large components, I can always go in here and manually change and add more height to my safe travel. Likewise, when we start a height setup, the tool moves to its topmost position. And so I usually recommend running a height setup, especially when you're starting with a new part, you put a new part on, And then you have now even more clearance between the part and the tool when you first load your device. So now that the part is loaded underneath, the tool is set up, I'm gonna go ahead and follow the prompts on the screen. So after we hit height setup, it says move to the first bond and press the bond button. If we look here on our control puck, so we call this the control puck, you can call it the mouse or the joystick control. So on this, there is a green bond button right here. Kind of can see it. And then there's a red reset button in the front. And then these black are just caps for buttons for other things that are not used on the HB30. So it's just a green bond button and a red reset button. The software is built on DOS, so it can only handle one command at a time. And since I told it I need you to do a height setup, the system is now only looking for when the bond button gets pressed to execute this command. If I launch the height setup and I didn't need to, I need to hit the red reset button to abort out of it. So if I hit the red reset, I am now out of my height setup. If I go back into my height setup, I need to either complete the height setup sequence or reset out of it. If you reset, it'll just use the height sequence that was done previously. So I'm going ahead and going to press the bond button. The tool is now moving down slowly. I can micro manipulate the puck. I can micro manipulate the work holder. Tool comes down, registers the height on our first bond point. So now we're going to come and do the second one. Again, I can micro manipulate, adjust, target. Height setup is complete. And now you can see the bottom of the tool just peeking at the bottom of the microscope. And this is our automatic height, work height that we set. Again, I can go in here and say, what if I want this closer? So I can shorten this number. And now the tool moves down. Or I can say I need more height. And so now the tool is completely out of the way. After the height setup is complete, we can then start doing our first bonds. You would then want to set up the control screen. So let's start with the control screen. Oh, too low. Right.
I think it looks clear to us.
Yeah, I want to try to fight the autofocus. And prevent it from spinning. How is right there? That's good, right? All right, so we have our main bond screen. We have our height setup button again. Next to it, we have a test USG button. So this is a test ultrasonic generator button. If we weren't sure whether or not the ultrasonics on the system was running, we can click this button. A timer is now automatically running. The system is producing full ultrasonics. And then what you can do is you can take some tweezers and touch them to the tool. You can start to hear, you might not have been able to hear it. It's a frequency, pitch, vibration, or harmonic that I'm creating with the metal tweezers and the tip of the tool. And now I know the ultrasonics is definitely vibrating, and I can hear that harmonic resonating frequency when I touch a metal object to the tool. So you can see it says ready. So if you accidentally click test ultrasonic generator and walk away, it will automatically get turned off. I think it runs for about like 100 seconds. The next two on here, we have Y loop H and Y way. So loop H is our initial upward Z movement. These numbers are in microns. So after the first bond, it's going to move up in the Z direction 4,000 microns. And then what it's going to do is automatically move forward in the Y direction 3,000 microns. And that is the basic shape of our loop. We have it under a program number. So with any of the numbers, you can double tap and then the keypad will show up. The keypad shows the lower and upper limit of whatever parameter you're looking at. If you start to write a number and then click delete, it'll show you what the old value is, and you need to say okay to accept that value. With the program number, you can store up to 100 programs. Each program can have a name. The name can be a combination of letters and numbers. And then we have our bond 1 parameter, ultrasonic time and force, bond 2, ultrasonic time and force. The next is the bonding mode. So it'll always stay in wedge mode because the heavy wire bonder is a dedicated wedge system. And then this bottom is semi-automatic. So this is our bonding mode. Right now I'm in semi-automatic mode, which means that I'm using the bond button on the puck to control all my semi-automatic moves. The alternative is if I select semi-automatic, it'll switch manual, and then the manual Z is now in control. And we'll review that as well during bonding. If we continue to hit manual, the next choice is step. Step mode basically means that you have to push the bond button every step of the way. So the first time you push it, it will just do bond 1. The second time, it will just do the loop H. The third time, it will just do Y way. So if you had a complex loop shape and you wanted it to step through it, and so you could see how the wire is manipulating, that's when you would use step mode. And of course, you have fully automatic, which I don't think anybody uses. But basically, you can only push the button on the first bond, and then it automatically moves up, moves forward, comes down, and automatically does the second bond. Not very recommended unless you have a very repeatable sample and you need to put 10 bonds that are identical right next to each other, then you could potentially use semi-automatic mode. But primarily, you'll be switching between semi-automatic and manual mode. They're the two most popular. The next area is advanced settings. Will take us to our setup screen. So the setup screen again has our height setup button. We have search height. So SH bond 1. This is search height for bond 1. This is the search height for bond 2. The search heights are automatically the touchdown height plus 400 microns. So these touchdown heights are not the surface height. They automatically have an offset to allow us to do micro manipulating when we're doing our targeting. The next area is a whole cut sequence. This, you can definitely get the up, back, and knife up, these 4 on the top, out of the book. I basically always start with the recommended settings that are in the book. And then the last one is the cut. So the cut has to be a guess and check found out number. It's based on how the cutter is actually mounted in the holder, what position it is, how far up it is. And so what we're doing is we're calculating how far the cut sequence needs to come down to actually cut the wire. So you can start with a large number and overcut it and then back down to minimize damage to your pads. Or you can start with a low number and then just keep working your way up until it finally cuts. And we can play with that. I can show you what a low and a high number look like. The next sequence is loop parameter screen. So if you were adding complex loops, these loop H and Y way are the same from the first page. You can see we have upward Z, forward Y, but I can also change this. I can make it down or back. So I can add any combination of Z or Y movements. Everything's written in microns, and I have an example that I can show you about loop parameters. The last screen is the miscellaneous screen. Here you can customize the lighting. So this is the percent power for the lighting. If you want more lights, you can add up to 100%. 75 seems to work most. We have fixed count, which is how many bonds the life of the system has done. Job count is a counter that I can reset. So if I want to, I can hold my finger here and then I'll reset to 0 if I'm trying to count how many bonds I did. If it does 1 bond, that's 2. 1 wire sequence is 2 bonds, first bond, second bond. The other here is a search speed. So this is the speed the system is coming down when you ask for do a search height setup. 10, I believe, is the lowest it goes. And I usually always leave this on the slowest. And then motor speed is the speed that the motors is running while after the first bond is done. So how fast will it come up to our loop height? How fast forward will it move? If we have a complex loop, if you slow the motor speed down, bending the metal, the wire will be more repeatable if we do it slower. There's a stitch button here, which I'll explain if we need it or planning on using it. And another popular button is the Save As button. So this program is ready. It has done a height setup on it. I know that these are good bonding parameters. If I say I now want to take the same program and add a complex loop shape to it, what I can do is just say miscellaneous, save as, and go to 32. And now I'm running on program 32. It's a duplicate of 30, which is what I was on before. And now I can do some manipulations to the loop parameters without ruining the program that I had originally made on 30. So we're just going to stay back to program 30. And that's the basics of the control screen. So now, all right, so now if we want to get into our actual bonding and we position our part. All right, so I have my hand over here. I'm in semi-automatic mode. Clicking and holding the bond button, so the green bond button on the control puck, clicking and holding that button down takes me to my search height for bond 1. Here I can micro manipulate. I'm hovering 400 microns off the ground. And then when I position to the pad or target that I'm looking for, I release the button. The system automatically moves up 4,000 microns, which is my pre-programmed loop H. And then it automatically moves 3,000 forward, which is my programmed Y way. It will then sit up at this second area, waiting for me to press the bond button again. So now when I click the bond button a second time, I'm at my second search height. Again, I can micro manipulate. I can go further out, or I can pull some of the wire back if I needed to. But all my manipulation is done manually. When I release, then the second bond is done, and then the cut sequence automatically happens. So let's just do that again. So again, I'm clicking and holding the bond button down. I get to my first search height. I align, I release, first bond's done, moves up, moves forward, click and hold again, get to my second search height, release, second bond, cut. So now let's just change the program to program 31, which is a duplicate of this program. The only difference is I have a loop profile in here. This loop profile takes me out further than the second bond. It comes down and then buckles the wire backwards. So to see that, I'm now clicking and holding again. So right now I'm in the loop parameter screen. We don't care what screen is visible here for you to actually launch bonding. Sometimes it's nice to be checking your loop parameters or developing this and be on this screen when you do the bonding. So there's no reason you need to come back to the bond screen to actually start bonding. You can bond in any screen. So I'll click the bond button down. I'm now at my first search height. I release, and now the tool automatically comes and does its loop shape. I then do the second bond, and now you can see the loop is 3 times as high as the one next to it, and the length is about the same. if we wanted to see what that looks like in, say, step mode, I can have the tool slowly step through it. So if I click and hold, I get to my first bond. All right, so it's waiting. It's touched down to the surface. I click again, it does the first bond. Click again, it then moves up. It then moves forward, it moves down. It then comes buckling back. And then it's ready to do the second bond. Second bond is done. And now it's going to start the cut sequence. So if we remember, there are 4 movements in the cut sequence. So clicking the first one, this is our up. So the up sequence just needs to be at least the diameter of the wire you're using. Then the next one is the back. The back needs to be at least the distance that the bond takes up, which is typically about 3 times the wire diameter. Then there is a knife down, and this is the parameter that needs to be adjusted after a tool change or after a new wire, or if it hasn't been developed yet, the cut is done, the tool cut moves up, and then the tool slides back. You can also have a upward slide as well, but I prefer sliding back. And now it's complete. And that is the whole sequence in step mode with a loop shape. So I'll go back to 30 as a simple. I'll stay back in semi-automatic. And then we can just go back to our, I guess, more boring wire with just an up and forward movement. Likewise, we don't actually need to have a loop shape. Let's say we're bonding something and it's very delicate and I can't run a height setup on it, and I'm planning on running it in manual mode. So if we switch the system to manual mode, the Z lever is now my control for the Z head. And the way this works is I don't actually care what my heights are, as long as I can touch down and detect them. So while I'm moving the head down with my right hand, I'm in control of the Z. Once it touches down on the sample and I release, actually I'm not going to release yet. So I'm still pushing down on the sample. You can see I can push down even more. So we prevent over travel. The proximity switch detected the height at this, and so we know what that height is. And now it's just waiting for my hand to kind of move back up. And now it's going to follow my hand. I'll move forward, I'll move down, maybe I'll move back. And then when I continue to press down for the second bond, again, now this time it's going to wait for me to come all the way back up to reset. And then it's going to automatically do the cut sequence for me. It's going to automatically execute that cut sequence at whatever height is the second bond in manual mode. But it also doesn't hurt, even if you're planning on running it in manual mode, just to do a height setup. That way you know that the system heights are set fine and that the work height is now set. So that's my 2 cents. I'm just recommending that. That is all there is really on the basic operations of the system. If we don't have any other questions, I can start to take it apart and show you how to install the wire. And then we can do a little bit more of an in-depth look at what's happening here, all the moving components, parts. So let me know if there's any questions, or should I just continue on?
So Jonathan, I do have a quick question.
Sure.
So you see these 2 wires have the clearance. What's the minimum clearance this machine can do?
So you mean clearance in terms of a part that you can fit under?
Yeah.
Oh, okay. So the clearance right now is, it should be 22 millimeters.
Oh, 22 millimeters. Okay. So what I'm saying is that you see these 2 wires have the gap, right?
Oh, you mean the pitch?
Yeah, exactly, the pitch, yes.
Oh, so what's the finest pitch?
What's the finest pitch? Yes.
Okay, so the pitch is actually defined by the tool manufacturer. So and there's only really three major tool manufacturers, but the pitch is defined by them. Their ability to create the tool width that is paired with a specific pitch that we're trying to achieve.
Okay.
So this is a standard tool. There's no fine pitch characteristic to it, and you can see I can probably put the bond within, within the tool spacing.
Okay.
So right now I'm only limited by the width that I need to have to just have the tool bumped up against it. If I needed this to be finer, then I'd just talk to the tool manufacturer and ask them to shave the sides if I needed a finer pitch.
Okay. Yeah, I forgot the one in our lab. What is that?
I think you have 250 micron, or maybe I can check. I have it written down.
Okay, thank you.
But yeah, we usually find pitch is not that big of a concern with heavy wire just because the pads are a lot larger. And so the likelihood of having a pitch that's less than, say, 100 microns is probably pretty rare. But if you need something like that, we can definitely talk to the tool manufacturers and see what kind of designs are out there.
Sounds great. There's one question in the chat box. Could we bond the 3 points with one segment of wire, then cut the wire?
Absolutely. So stitching, we will demo stitching for you right now.
Okay.
Actually, we're going to demo two different things because the stitching kind of incorporates what we call the dynamic search box. So the dynamic search box, all right, basically allows me to manipulate my search heights on the fly. So when I click it, let me see what mode I'm in, semi-automatic. So when I click and hold the bond button down and I'm hovering above the surface, if I felt like I don't have enough clearance, or I actually did my height set up here, the pad is actually a little bit higher. What I can do is I can use the up and down buttons to manipulate my search height. I can make the manipulation a permanent, so where this height is now saved to be used on the next sequence forward, or I can switch a bit and make these changes temporary. So that each individual wire sequence, I start with the original parameters and I'm adjusting per wire instead of an evolving like step up. So I can manipulate this, I move up and down, and then I'll complete the first bond. All right, so once the first bond is completed, I can now tell the system that I want to do stitching. So that's this button over here. It's called the stitch button. So if we hold down the stitch button, I now am in a continuous stitch mode. So if I get to the second bond, I do the second bond. The system now is told that I'm running manual stitch, and it will not terminate the wire until I let go of the stitch button. In this example, we're just going to do 3 bonds. So I let go of the button, and now it's going to do the third connection and do the cut sequence. So we have 3 connections and a whole wire sequence. If I knew in advance that I was doing that, I can hold the stitch button now before I push the bond button, and now I can push the bond button. And then I can let go of the stitch. The screen says automatic stitch. And so now I know stitch mode is automatically enabled. It's going to allow me to do 2 loops with 3 connections. First, second, third, and automatically execute. If I needed more than the 3, then I would just need to start the, and I just needed to press the stitch button after the first bond. So once the first bond's done, if I just hold stitch, I can continuously bond forever until I release the stitch button. And so you have about 17 millimeters of motorized Y travel for the stitching to be motorized. At some point, I'm going to run out of motor, but I can still always move forward manually. So that's just the limitation for the motor. But again, stitching. And then for stitching in the control screen, let's just go back here. So if we go back to miscellaneous, we see we have our stitch button here. Okay, so this stitch button can be toggled between 122 and 121. 122 is a little bit more popular, and 121 is kind of application specific. But basically what that means is in 122, it means that when I'm doing stitching, it's going to use first bond parameters and then continuously use second bond parameters for all the other stitches. Alternatively, I can have 121, which will mean it will flip between first bond parameters, second bond parameters, first bond parameters, second bond parameters. Typically, I find 121 used in fine wire applications for solar, and they are stitching cell, module, where those parameters each kind of, all the cells have the same bonding parameters and all the modules have, and they alternate. More commonly, the 122 is your main component is maybe a silicon component for bond 1, and then 2 is maybe PCB or non-silicon or a connector, and then another sub-connector. So usually the 2s are different than the 1, the first bond. So, and again, I can always re-review that, and we can talk about different loop shapes if you need to add loop shapes. If you had a loop shape in here, it would move this loop in between each of the stitches as well. But if there's a lot of movements in your loop, in your Y-way while trying to travel a far distance, you kind of lose some travel creating the loop, but it's a very rare case. Was there anything else in the chat?
Any other questions?
Oh, that's it.
It's like once the wire is stitched onto the board, there is no way to take it off or anything to manipulate it.
So removing wire, is that what the question is?
Yes.
So, yeah, typically when I remove wire, I'm left with like the bond itself, and I'm able to pull off the wire. If I need the bond removed, then you kind of have to come in with tweezers, and depending on how hard the bond is, it may be difficult to dislodge. If I move down to some of my finer wires, obviously, if I go over here, I do have some finer wire. So this is like 100 micron wire, or 150. So you can see this is a lot lighter, and I'm able to just rip the bond off. But it kind of just depends on the strength, what materials are being bonded. So obviously on here, I'm metal matching. I have my aluminum wire, it's bonding onto an aluminum plate. So the lattice structures line up better. And so it's a better adhesion. If let's say I had a copper substrate that I was bonding to, I'd be more likely easier to rip off those bonds. Copper has more oxidation, there's a cleanliness, and I'm not necessarily metal matching, so I could potentially remove it from there. There's also, for mil specs, there's not an issue if you had a pad and it already had a bond and the second bond didn't stick, and during its during its cut it moved up and then pulled this wire off. You can rebond on top of the bond. It's not impossible. I just didn't have any room to do my cut. But as an example, you can see I just have this wedge right on top of the previous bond. So if I was trying to baby apart and I didn't want to grab a new one because I now have a pad that I have a bond on, you can technically bond on top of a previous bond. especially because the material will be clean and fresh anyway. So it should be easier. All right. So I think if that's all the questions in terms of bonding, do we want to, I can maybe talk a little bit more of bonding parameters and maybe the cut sequence before we go into the installation.
Yes, that'd be nice.
All right, so again, we will go through installing the wire and adjusting so there's 3 components that we will talk about. It's the guide. So we have a wire guide that's positioned behind the tool. We have the wedge tool that's in the middle, and then we have the cutter in the front. I have another diagram that I'll share, and when we actually talk about these pieces, we'll go in more depth. But for those 3 components, once they are installed, we will then need to decide what our cut sequence is. So as an example, I will put the cut sequence very low. So the range of my cut is 2 millimeters. I need to make sure that I have the cutter within 2 millimeters of my cut movement. So I moved it down to 1 millimeter, which I know is too short. So I come down, do the first bond, do the second bond, and then the cut didn't even come far enough down to even put a dent. So there's no mark on the wire, on the top of the wire at all. So I know I definitely have to go a lot more. The tool comes with this little guy. So these cutters you can position upside down. There's an angle on the tip, so it helps you kind of get in here and cut the wire. That way you don't have to be tearing and pulling things with tweezers. So I'll cut the wire and then reposition it. And now we'll add, I start with 500, so I'll add 500 to it. All right, do second one. Okay, second bond. All right, now when I zoom in, now you can kind of start to see the cutter is starting to cut the wire. I can also look at this as this is my distance. So if the back distance wasn't enough, or I felt like, it could probably cut a little bit closer to the edge here, or if I wanted to cut further out, I can manipulate that here as well. But I clearly see that I'm just about approaching the wire. And I know that the wire is 200 microns thick. So it's not a hard guessing game. I'm going to add 200 microns to this. I'm now at 17. I will just manually assist in this tear. So you just kind of wiggle it. So you can see the wire was almost 60% torn, but I'm going to give it a little extra. And so now when we're in this 70%, oh, too zoomed in. All right, so now it's 17. Cutter just, so we get about, we're at like 80%. You see there's a tiny bit still connected, and that's when I added the extra 50. So that's how I arrived at my 1750. Again, we can do the whole sequence all over again. All right. Another handy thing when I'm doing, just trying to figure out what my cut sequence is if we move back to the main bond screen, above where it says bond 2, we can actually click bond 2. And so now the system is just saying we're just going to do the second bond and the cut sequence. And I don't have to constantly put first bonds in just so I can get to my second. So now it's just going to do second bond and cut. And now it was a successful cut, so I know I'm basically done. And now I can go on to manipulating more of my parameters. Just get some of this material out of the way. If we look at our bonding parameters, the book basically gives you a range of starting parameters based on the wire diameter. The science behind it is we have a minimum amount of force to get good thermal compression on the wire to get good ultrasonic energy transfer. We have a minimum amount of time that we need to spend there applying our ultrasonics to get good adhesion. So time is usually the last parameter I change. I pretty much use 200 milliseconds for first and second for a lot of different applications. It's only when I'm really diving into the application specifics, if I feel like I need to manipulate the time, it's rare.
So Jonathan, can you zoom your camera closer, move your camera closer a little bit to the screen?
Sure.
Thank you. Yeah. Thank you.
There we go, perfect. All right, so again, we have ultrasonic time and force for bond 1, bond 2. Force. So force is a, oh, sorry, a little high. Force is a minimum compression required to hold the wire in place while we apply ultrasonic energy transfer. Time will probably be the last parameter you manipulate. And so the first thing you want to do is have basically an ultrasonic setting, and your first goal is to try to find the force. You know, if you're starting from scratch and developing. So let's just take this down, and we'll lower this down as well. So I got the first bond. I'll put it close to this. All right, first bond. So now I'm just going to compare, basically, this is the first bond that I did, and now this is the new bond that I did. So the squash on this, so I usually like to have the cutter, the wedge tool kind of fan out the sides. So I already see that there's the fan on both sides, so I'm okay with that. This bond actually looks better than this first one. So the parameters that I'm using are probably just as fine. And then I would have to do a real pull test to see if the forces that I have are enough to adhere this entire surface area. So let me see. Yeah, so for me trying to pull it off, basically the bond still remained. So I could say that the parameters, that these parameters are, you know, just as good. So this is 200 less and almost 200 less in both ultrasonic and force.
So if this force is too big, is that going to break the tool or break the die?
So you could have cratering. If your forces are too high, then it could potentially crater the pad. Or if it's on silicone, a silicon component, then you kind of have to play with both force and ultrasonics. Even if the force is low, if the ultrasonics is too high, that vibration will have micro cracking and other, you know, it could potentially vibrate past pad layers to underlying layers and cause micro separations between some of those layering. So usually when we're bonding on the actual silicon component, we're going to baby the parameters and basically just get up to the minimum visual inspection of a good bond, I think is the best bet. And then if you have failure analysis that you need to do, and you can do some pull testing, typically in the university space, it's not like you're producing product. So, you know, your bonds just need to be strong enough to stay, to run through a test cycle or whatever other experiment you need to run. But, you know, it doesn't necessarily have to be pretty either. So A lot of times, you just want something to stick, you just want it to bond, and I don't care if it doesn't look the prettiest. What parameters would I need to get there?
Yeah.
I find that for heavy wire, the range is a lot wider than fine wire. I usually don't have many conversations with my heavy wire guys where they say they're not sticking. It's more of fine tuning the adjustment of the cutter. So I actually had my cutter installed earlier. Where was it? I made some adjustments. I'm just trying to see if I can show you. All right, so some of these bonds, once I move this. So some of these bonds in the beginning. So let's see. You can't even really see it because of the little bit of a optical illusion. These are a little bit bigger. So you can kind of see for these, this is the bond area, and then this is what we call the front tail. And so sometimes I'd say not sometimes, a lot of the conversation is how do I minimize this front tail? So in this, I had already manipulated it, and the tail is about half the size of it that it was before. So these bonds that I've been doing recently, I have already moved this in. And this area is basically done by the gap width between the cutter and the wedge tool. So that's a common conversation of how do I adjust that to minimize the tail, and it has to do with moving the mechanical screws in the cut sequence, getting the cutter as close as you can to the wedge, and then kind of slowly backing it off until you can achieve the minimal tail. Other than that, it's basically figuring out loop shapes. So you'll have more difficulty creating a nice loop when the first and second bond locations are at the same height. When I don't have a height differential to assist in my looping, then I'm kind of forced to create all the looping in the air prior. So that's why if we just switch to manual, coming down doing the first bond, coming up and moving forward and coming down isn't going to really give you that big of a loop. Just ignore that one. But now when I go manual and I come up and I go forward and then buckle back, that's when I'm really creating a more variable loop. So if you look from the side, if you needed to create an actual loop and the heights are the same, I gotta kind of overshoot and buckle it back to get it. Because if I only stay within this geometry, it's gonna want to flatten itself. The loop behind it isn't a flat loop. It is fully lifted off the ground through the whole distance, but maybe I start cutting close and cutting into something here that I'm worried about, and I want extra height here, or there's some component I need to jump over. But in standard, if we're just using an up and a forward, it's definitely going to have a lower loop. All right, so that would be the adjusting the cuts, the parameter adjustments. I'd say, you know, as a rule of thumb for parameters, I usually go on the higher side. I'd rather over bond than have lift off. Then I know I'm already in an area where I'm already over bonding and it's just a matter of backing down parameters. If you start at a really low and you're not sticking, then you're constantly attempting to not stick somewhere. I always feel like when I do a non-stick attempt at a low parameters, I kind of picked up maybe some material on the bottom of my wedge or the wire that's sticking under the wedge. So if you do start low and it's not sticking, I recommend taking some wire and pulling out some fresh new wire on a new tested sequence. Or just, you know, use very high parameters, over bond, and then the following sequences just lower them. I think kind of ready to go into the inner components. Let's see, I don't think there was any chat questions. No.
Johnson, I just want to see if my understanding is correct. It's like I feel this bonding machine is rather similar to a sewing machine. Like once the bond wire is like situated with the wire guide and the cutter, the like that you mentioned, the front pair would stay uniform.
Yes. Yes, wire bonding is very often compared to like a sewing machine. In the sense that once your sewing machine's all set up, everything is threaded, you know, you should be able to go for a while. There's some cases where the wire, you know, the string or the wire gets pulled out of the needle or the wedge tool, and therefore a rethreading is required. In our cases, most likely, the scenario would be that the wire is just not positioned under our tool. On that sequence, let's see if I can. All right, so we have the front of the tool, and maybe the wire is now coming off the side. So there is a groove on the side of the wedge tool. So I have another picture I'll show you where this will make more sense, because if I bring the camera in, I feel like it's just going to constantly autofocus. But, you know, basically all I need to do is just bring this back to underneath the tool. So once the wire is underneath the V-notch groove of the front of the tool, I then just kind of like pull it up and let it just kind of be wrapped under the front of the tool. And that's basically, you know, a more common correction. For wedge bonding, we can only bond from a 6 o'clock to 12 o'clock location with maybe 3 to 5 degrees deviation. So 1, 2, 3. So seeing that, so now I have the first bond done. I come down, second bond. I always recommend coming down if you are needing to add an angle. And basically, I can only go as far out as keeping the wedge under the tool. So once I get, I mean, now I'm in the 20 to 30 degrees almost. I have to back up. I won't be able to do it until about here. That was just a little shy. And so maybe if, you know, maybe if I doesn't cut 1 or 2 times, then I'll go in here and add, you know, an extra 20 microns. It could just be that one sequence, that one time that it didn't cut. But once it's dialed in, I usually find it extremely consistent. But I was doing something a little non-traditional. I tried to make an S shape, so I can understand. But yeah, you're always primarily going to set yourself up so that you're bonding from 6 o'clock to 12 o'clock with minimal deviation. And if you did need to bond from here to there, I would say just rotate. Rotate the work holder. You can also rotate the part in the air. So after the first bond is done, if you want, I have seen very non-traditional rotations in the air. As long as you can keep the wire underneath the tool, it's a fun game. And then you can get, higher angle. Again, this is not traditional, and usually people don't create scenarios where this would have to be the way they need to bond. But I always recommend just rotating the tool, the work holder, so that everything is aligned.
Okay, thank you for your demonstration.
Not a problem. All right. Next fun thing, adjusting. So let's get the wire. We'll back up. We'll get the wire installed, and then we'll go through the tools. And then what I'll do is I'll bring up a page from the manual. Okay.
So Jonathan, how much time do you have this afternoon?
Plenty.
Okay. That's good to know.
Yes. What time is this class over?
We will be over by 2:25. It's about 15 minutes later.
Yeah, I think I have about another 10 minutes worth of things to show, and then we can leave the whole rest of the time for questions.
Sounds great.
Or I just keep showing you more things until we run out of time. Not a problem. Oh, can't see. Okay, I can see now. All right. So the covers on the system all pop off. All right, so the covers, there's little ball bearing springs. There's the one right here, there's one right here, there's one right here. And so basically when we want to put this back, we can just slide this into place and it should click nice in place. So removing that, we have our wire. We have our wire right here in the wire spool. There is a little locking nut in the front. So there's a little locking nut that was probably already put onto the system. And some people decide to leave this off. It doesn't have to be on, but you have it, might as well use it. All right. And then we have our spool. All right, so we have our spool. The spool will tell you what start color and is the start color for the spool. The start color for this spool was the green one, and the red one is the stop, so the red one will stay. I undid the green one, and now you can see the wires flowing clockwise, so it's going to flow off the top of the spool clockwise. I usually kind of keep it wound taut-ish when I put it in, but that doesn't always work. And then I just kind of take my hand and feed this wire right into the clear tube. Yeah, of course I missed. All right. So then all I'll do for this is I'll take out this loop that's here so that I have all this excess materials in front of the spool. I don't want anything to get twisted or tied inside the spool. So if I do have excess, I'll just typically pull it out over here because I have to run that through the rest of the tooling anyways. Now you can put your little lock back on. Okay, and we can just put the cover back. We'll leave it open for now.
Do we usually order these wires from DigiKey?
I don't think DigiKey sells wire, do they?
I'm not sure. Yeah.
I usually either, so the heavy wire I usually get from Heraeus.
Okay.
Depends. So aluminum, I believe, is made out of Germany, and copper, I think, comes out of Malaysia. But there's a U.S. component counterpart that you can talk to, and then they'll figure out where it's going to ship from.
Okay.
I usually have some limited stock on certain sizes in Germany at the TPT facility, and then I have Amatec. Amatec Coining is represented by Topline in the U.S. They're also another good resource. I often get wire, and I'm very pleasantly surprised about their lead times. I find if I order from Heraeus directly, then it's shipping from Malaysia, and then it's like 10-week lead time.
Okay.
But I have resources here in the U.S. for both wire and tooling, and some of them pleasantly surprise me with better lead times, and I usually find the quality to be pretty much the same across the board. They're all following mill specs in creating the wires, so I haven't really found any really big discrepancy between one wire manufacturer and another. It's just all about price and lead time. All right, so let's get this for here. All right. So the only thing you're not able to see is just the wire, which is right here. Okay, it came out of this hole, which is also connected to the plastic. So this is the plastic tube that ran all the way back inside. All right, so we just ran the wire from here down into, and then we're going to run it through the hole in the transducer, and then we're going to run it in through the center of the tube for the wire guide. So I'll just position this back here. Also, while I'm here, might as well show you. This is our solenoid for our force. If somebody comes and takes this thing out, it's not broken, it's fine. I know that was a question that was asked yesterday. That's how we get access to a screw in there, and that's how we adjust the calibration on it. And then the other thing is, this is our force setting. So if it's all the way down, it's in the high force setting. If you pull it up and turn it, and then it's popped up, it's now in the low force setting. So you'll use the low force setting up to 200 micron wire diameter. Everything above 200 micron wire diameter, we then use the high force. All right. So that's just that little piece of the force. All right. So now we're going to take our wire in through the transducer hole, in through the hole for the guide. And then what I usually have to do is take the guide out. All right, and then I just need to make sure that the wire is coming down through the center of the tube and not out one of these little groove slits on the side, and that's how the guide gets held in place. So we have our guide here. There's a little hole in the back of the guide, and that hole will then run, there's a slit here, and then it runs down a whole slit on the right side of the guide. And then the very, very tip, there's a groove to hold the wire as well. And so usually what I do is I'll take some wire out, I'll put it in the guide, let it come out the back. And now basically I have my wires through the guide already. And so now we'll put the guide back in place. If you're having difficulties installing or taking the guide in and out, pinching it and sliding it in is easier. A brand new guide, you know, it is a little bit stiffer, and then over time, as you constantly are putting them in and out, they'll wear, and then they'll slide in and out a little bit quicker. But a brand new one might take a little effort, but it's not hard. And you can always use the tweezers to assist you. They'll fit in these little slits on the side to help you to push the guide up or down. So then I just take the wire, and I'm just gonna feed it into the side of the guide. All right, so it's just, I just followed the groove and it just fell into the side of the guide, and now it's gonna sit right in the center of the guide. And now I have to do my adjustments for my cut sequence and the wedge tool. The wedge tool I have, you'll use a torque wrench. So the torque wrench goes into the front here of the transducer screw, and this torques that at 35 centinewtons. And that will be the torque for the wedge tool. And the wedge tool I have is flush with the top of the transducer. So this is the wedge tool, flush with the top of the transducer. And then we have our cutter. We have, actually let's back up into the guide. So you have these two screws here. So these will help move the guide in and out. There's a little bit of an angle play, and there's a little bit of an up and down, but it's mostly back and forth and a little bit of a wiggle. If you really need to increase the height or bring this down or up, then I would suggest loosening the screw and then actually sliding the whole tube up or down if you needed to make that adjustment. Other than that, I find that the wedge tool doesn't really ever have to get adjusted. I'm mostly adjusting the cutter so that it has that 2 millimeters of cut distance, and then I make the guide fit into that. There are some scenarios that I have had where installing everything as is, the cutter still does not have enough distance to come down to do the cut sequence. If that's the case, I find it's easier to just raise the wedge tool up a little bit. So you can always have tools a little bit higher than the transducer. If anything, I'd rather it be higher than submerged. If there's a little air gap on the top of the transducer, then we're losing ultrasonic energy transfer. If it's raised a little bit, you're not losing some, the vibration is still going up. We lose a little bit because it's turning around and coming back down, but I find that the loss is a lot less than if you had an air gap, and it definitely makes the management of the tooling easier. So that is the parts about the tooling. I can definitely go into doing some more bonds. Let me share my screen. Share my Adobe. Say Let's make this bigger. All right, so, and I can also send you these PDFs as well in case they weren't found or seen. But basically, I like this one because it shows the guide, and then we have the wedge tool, and then we have the cutter in front. Okay, in case there was any communications about the positioning of these. These are just some more dimensions, but I like this picture just because it shows these three as a side view profile. When we go back into the, oops, into the actual operations. This is where you can then start to see how we recommend having the wedge tool flush with the top. You can see in here that it is sticking up above, so it's not necessarily bad. And that here are some example positions, recommended offsets. So we want the guide to always be a little bit higher than the back of the wedge. But you can also see here's the cutter and here's the cutter. There's almost, you know, less than 100 microns of space between the cutter and the wedge tool. So those are the kinds of geometries we're looking for. You can also kind of see how high up it is and how fairly close it is, and how sometimes the guide is really close to the back of the wedge tool. You can see here it's almost touching. So there are a lot of different scenarios where the guide is positioned a lot higher up or a lot further back, and that would manipulate your loop control. I find if you settle on a shape for here, then the loop control and your looping parameters will help change that. That's the V groove notch. There's another picture. Oh, that's the same one. Oh, it's down at the cutter. Adjusting the cutter. Sorry, it's easier to get me to the table of contents. All right, so now this is the front and this is our cut sequence. So when these two screws are removed, all right, then the entire cutter, so this is the entire cutter flipped backwards. All right, so now what you see on here is there are these two fine adjustments set screws. These will be used to help make your fine adjustment on bringing the cutter closer to the wedge. The major screws are for more of the coarse. So these two front screws will help determine how far, well, these two actually lock the cutter in place. When they're lightly loosened, you can use them to manipulate a little bit up and down, but I pretty much always put it in the most down position, because at the top here, there's another set screw in the top here. Actually, do we have it? So here, you can see the top of the screw here. And I usually like to set this distance to fine tune my up and down. So this distance here would be defined by this set screw here. And then these two screws in the back, they would change the forward and back, but you can see there's a gap here, and that gap is by these two set screws. Installing the cutter is pretty standard. There's two little set screws and a bracket at the bottom. There is a groove in the bracket that the cutter will fit into. The cutter also has the printed part number on it. And so the rule of thumb is you want the part number to face you if you're questioning, or you want the angle of the front of the cutter to be facing away. So usually I just say find the part number and make sure that's facing you. And that's how you'll mount it in here. So you'll mount it in here with the part number facing away so that you can actually see it here. Right here, there's a little white, and that's some tool, that's a part number on this tool. So I usually will back out the set screws from both the top and the two that are in here, these two, so that I have about 100 microns to play in a gap here and about 200 micron gap to play with here. And then I install everything and I put everything back. When we are adjusting, so I try to put these screws in a position where a rotation can be calculated on the same one. So when I put the Allen wrench in, if I rotate this 90 degrees, I know I can put the Allen wrench in the same and not rotate it the same. That's usually easier, quick rule of thumb. And you're usually only making about quarter to half to an eighth of an inch turns. Once everything is installed, you will then get yourself into a position where the cutter is as close, if not touching, the wedge tool. Once they're touching, what you'll then do is you'll start to move these two set screws about an eighth of an inch at a time until you create a gap here. And that's kind of how I quickly set up my and minimize the tail. So this distance here is the distance that the front tail will exhibit. After the front and back is basically set, you know, as long as I have enough travel distance to do the cut, I shouldn't have to readjust the up and down. If I do need to, I have basically a couple hundred microns in this set screw to help lower it down. When you do lower it down here, you will need to loosen these screws here to allow it to sink down. Same with the front and back. So you do have to kind of loosen these a little bit to help it move back out. However, when you're just doing the fine adjustment for the spacing, I make these tight and then I just do eighth turns in the set screws, and that will just add enough pressure to push it off of the wedge wall. That is everything. All right, how do I stop sharing?
So Jonathan, is this all?
Do I have to turn the camera back on?
I think we could see your camera now.
You saw my PDF before.
Yes, but now we are seeing your camera.
Yeah, it said I can only share one thing at a time. So
okay.
Yeah, I just switched back to the camera.
Okay.
I mean, I can always switch back to the PDF. If there's any questions or anything that was on anything in there that you saw that you want me to explain or show you. I have a copy here as well.
Any questions? I saw everybody is quiet today.
I know it's a lot to absorb, but I really feel like after you get some time, you sit in front of the system, you start putting on your first sample, you start doing some of your first bonds, find some of your first issues, then the follow-up will be, okay, what were you able to accomplish? What weren't you able to accomplish? What parameters were you using? Did that work? Did it stick? Did it lift up? It'll be more of a development question. Yeah, I usually find that after a full day or one day of training, that everybody kind of needs to get their own feet wet for a couple of days, figure out some of the ins and outs, and then kind of follow up with a secondary training session. That's been very popular for universities.
I did share all the videos you did with Dr. Helen Cui the other day.
Yeah.
I think after today's tutorial, then I would recommend all the student team, go to the lab, play this machine a bit based on your instruction, then see if we have any further questions.
I'm currently piecing together my own HB30 training, where basically everything I did this morning, I kind of, dumbed down the video. I've edited it. I've taken a lot of the blank space out, and then I've added chapters in there, so you can quickly go to the chapter where he talks about the cutter, or the chapter where he talks about just the control screen. So I'm about 85% done with that. I just have a few more little videos. I wanted to add some application specific things, like what we did when the parameters were too low or high, or talk about inspection. So I wanted to add a little bit of that, just so your full tutorial video is kind of all encompassing, using the system, maybe a troubleshooter in there, but that any novice could use, watch the video and feel comfortable sitting on the machine doing something. We have proximity switches. We have, there are safety features on the system. So I should express that you should not worry about breaking the system. The system will yell at you before you break something. As an example, I'm coming over to this plate and I'm telling it the system, so I'm trying to go to something that's too high. So I try to come down to an object and it's touching an object prior to me getting to my search. It's yelling at me, it's beeping, it's automatically aborting. So if an operator at any time takes something over, they press the bond button and they're trying to get down to here to a search to do their micro manipulate, but they can't. All that happens is it touches and immediately backs up. Then they know that there's either the height setup wasn't done properly, but there's no damage to the tool, there's no damage to the wire. And now that I'm properly where I'm supposed to be, well, maybe I picked up some material. All right, so worst case, maybe I picked up some dust that was there, and so now there's a little contamination. But if you do the first bond, let's see, I'm trying to. So the system doesn't know your success. So if you do the first bond and it doesn't stick, let me see if I can shoot bond to this. Good. So it does the first bond, and then it says immediately we're ready for the second bond. And if you forget to do anything from here, it's going to just execute the second bond. Simultaneously, you do the first bond, and now we're stuck and we're in the second bond. If you hit the red reset, that will board us back to the first bond. Especially in the beginnings of development, when things aren't sticking, you'll be pressing the red reset to get back to the first bond again. Also with development, if you have the time to do first bond, second bond on something, then you can kind of play with estimating bonding parameters for both first and second and play with different parameters for both. If the material is the same, obviously I have it very easy here. I'm bonding aluminum on aluminum, but what you could do is during development, set up a test sequence where, the silicon component is definitely going to be the most difficult, but if we have a bare PCB or something, here's an example of a chip that I have. So here's a chip component. I have to bond onto the silicon, and then it gets bonded to these trace pads. But I have this whole area down here where it's just a giant trace pad where I could spend time just developing bond 2 so that I know that that's guaranteed to stick and cut and not have damage on the surface. And then I can go back to just worrying about what my bond 1 needs to be, because the bond 2 will definitely stick and definitely cut. And right now I'm just going to be doing development on bond 1. So I usually say if you can get bond 2 done first, then you'll know that you have the cut, you're not causing substrate damage, and that when first bond is successful, you know that the second bond will definitely be a connection. So yeah, this is an example of a high power device. It's still under development, so that's why it doesn't look as pretty, but and you can see, certain scenarios where it's a little bit of an S shape because the die wasn't positioned just right, but in general, the alignment is pretty much. And something like this, I could potentially use fully automatic, where the distances are all the same, the first and second bonds are going to be the same. And then if I finally have this program dialed down, then I know that I can just position the first bonds do the first bond, it'll automatically move up, move forward, come down and do the second bond. It's only, you know, like where these tiny little second bond connections where I won't really be able to use the y-axis to target a direct y movement accurately. And why should I have to, you know, pray? I should just use semi-automatic and be able to manipulate my accuracy on both first and second bond. So that's just a little example.
Thank you.
Absolutely.
Any questions from the students? So, Jonathan, is this all the demonstration for today?
I mean, I have time. I can continue on if there's other aspects or specific things. The HB30 is a little bit simpler than a fine wire system. We don't have temperature. We're not heating parts. The diameters of everything are a lot wider, and you know, so I don't have to explain threading a wedge tool. And so, yeah, so the operation and control is a lot less complicated.
Yeah, I feel the content today is already comprehensive enough for us to digest. So I would say maybe we just stop here, and then let us practice a bit. If we have some further questions, we definitely will come back to you.
Yeah, and that's usually what happens is, you know, everybody learns a little bit differently. Some people are more, I'm a more hands-on learner, and you know, I could read as many manuals as I need, but until I sit down on the system, I don't know what I'm doing.
Yeah.
And a lot of people, I feel like it's a very commonality in engineering that we are more hands-on learners. So I feel like a lot of things are concerns once somebody sits down and starts using it and they're like, oh, it does this for you, or it moved for me, or oh, I don't have to think about this, then they realize how much that the system is a lot easier than it is, and that all they really have to worry about is finding the right bonding parameters. And the system should always work as long as we find the right bonding parameters. And I'm here for you. If you have a sample or something, you can always mail it to my office and I can take a stab at it, give you my recommendations, tell you whether or not it's bondable, you know. That can also be a scenario too.
Thank you.
Absolutely. I'm sure we'll be in touch. You let me know how everyone makes out with, you know, the next few weeks or a week or two, and then we can definitely schedule a follow-up.
Yeah.
A session. It could be, you know, a session that's just operation, a session that's just application specific. So I'm very flexible. So don't worry, we're here for you.
I have already asked the students to go to the lab and practice. We will summarize all the questions we have, then come back to you.
Absolutely. I feel like they're, you know, practicing on the aluminum substrate is fairly easy. And, you know, okay, I did a couple bonds, I get it. It's going to be really when they start on the real sample. How do I develop this? Things aren't sticking. That's when more of the questions come up. So
for sure.
But I can be on both. We can have multiple sessions, not a worry. And hopefully one day I can get down there as maybe when it's warmer.
Well, we are warmer than your side, right?
No.
Yeah.
Depends on what day we're looking at the weather. I can't. It's kind of crazy these days. But yes, my goal is to eventually travel to all the 2020, you know, unable to travel to locations, and then just follow up, making sure, you know, various screws didn't become loose. There are certain things that could potentially become loose during shipping, which we'd already kind of reviewed, and you were already bonding, so it at least tells me that the system is probably fine. It's very rare that a major screw for component is loose. It's more of like an aesthetic. But yep, I think we are in a good point to stop, and
okay.
Let me know how everyone makes out, and I'm here for you. They can, you know, they're free to send me emails. They can ask me questions. That's fine too.
Will do. Thank you, Jonathan.
All right. Take care.
Have a good day.
Yes, you too. Bye-bye, everyone.
Bye-bye.
Thank you. Bye.
Thank you.